In this video we are going to replicate active haptics from a button press to passive haptics on a steady plate. First thing we have to do is finding the surface on the button, and we can do that through the software. This moves the ArFi down to the button quickly, and then it goes back up and slowly approaches for higher precision. Now we can start our measurement. This will press the button with a force of 5 Newton that we can set in our software. In the close-up you can see how the ArFi moves down and back up. We can also add a microphone to our setup that will pick up the sound of the button click. Now in our software we can evaluate the measurement. We can see that the acceleration of the Z-axis is lower when we press the button compared to when we release it. We can also load in the S-curve of the measurement. Here we can observe that the button press happens at a load of 2.3 newtons and the releasing of the button happens at a load of 1.6 newton. For inspecting further details, we can load the measurement in our haptic analyzer and we will find that we have most of the vibrations at 60 Hz. Now we want to replicate the feel and sound of the button using two actuators on a plexiglass surface. Like before, we are starting to find the surface using the ArFi. To control the actuators, we connect them to our HEBO. Now we can start setting up our HEBO. Inside our HEBO interface, we first activate actuator A. We can set a voltage and a frequency, and we can use the buttons to the right to fine-tune the frequency however we like. We can generate the wave and we can test it by pressing play. Then we activate the second actuator. But this time we don't set the frequency, but directly load in the wave file that we picked up using our microphone. We can manually trigger both actuators and hear and feel the replicated vibrations. In our software we can tell the ArFi to trigger the passive haptics at the exact forces of 2.3 Newton when pressing and 1.6 Newton when releasing. You can see how the actuators actually get triggered from the HEBO at these two forces. In order to validate that our passive feedback actually represents the physical button by feel and sound, we will conduct another measurement. In the graph you can see how the plate accelerates at the same forces, only this time we don't see any displacement. This means we have recreated the behavior of the passive button, and now we can start fine-tuning the feeling of our haptic signal to match the application.